All right, we're going to continue our quest on inequalities. We're going to work on compound inequalities because sometimes it's not just greater than, and sometimes it's not just less than. Sometimes it includes in between. Like for instance, in this situation, a tree can kick out somewhere between 1.3 boxes and 4.0 boxes of oranges. So it could include 1.3, and it could include 4, and it could include something in between. And in that particular situation, we use something called an compound inequality. And we're going to use the word and in this situation and an or. Both of those will show up, and we got to play that out. When you see the word and, that's when you're going to deal with some overlap. If it's got to be this and that, you want to look for that overlap. So for instance, in this situation where x is greater than or equal to 3 and x is less than or equal to 7, the overlap occurs right here between those two data points. So the solution to x is greater than or equal to 3 and x is less than or equal to 7 would be represented by this graph. If we're talking about an or, we're looking where each graph goes for the two inequalities. So for instance, x is less than -2, it plays out this way. X is greater than -1, it plays out this way. Now if you notice, they don't overlap, but they do go in separate directions, and we're indicating that as an or. To satisfy this would be anything that's happening here or anything that's happening here, and we're just paying attention to the dots. A couple of details you want to keep an eye on is when you're writing these inequalities, you can combine them. So when you see x is greater than or equal to 3 and x is less than or equal to 7, you can actually pull the and out, put the variable in the middle, and make sure, this is a detail here, is make sure your symbols are pointing the right direction. So I would read this as two separate chunks. The first part can be read as x is greater than or equal to 3 and x is less than or equal to 7. A word you're going to include here with this is actually the word inclusive. When we see the word inclusive, it means it includes the numbers that you see. So if I say x is between 3 and 7 inclusive, it tells you and me that it actually includes 3 and 7. That also tells us a little bit about the dot that we would be using in that situation. All right, I'm going to play this one out here. So we have all real numbers that are greater than -2. So I've got x is greater than -2 and x that's less than 6. I'm going to play that out. I'm going to pause this and work this out. All right, if I see x is greater than -2, it's going to be an open dot, and it's greater than. And then I see x is less than 6, but it's not including 6. It's going this direction. So my graph is going to be the overlap of these, not including the -2 or the 6. You would not have them. They would not be inclusive. Let's look at the B. All real numbers that are, so all real numbers that are less than 0 or all real numbers that are greater than or equal to 5. Let me set this up. So where n is less than 0, so it's less than 0 or greater than 5 or equal to 5. Notice this is going to be, I'm going in two separate directions. I want you to go ahead and try on number 1. I know they got it. Give it a try. Press pause. Let's see how you did. A couple things I'm noticing on A is an and, so that's an overlap. On B, it's an or, so they won't overlap. They'll go in different directions. I'm keeping an eye on the dots, which dots I'm using in these particular situations. And inclusive just means it includes both the -5 and the 7 in its answer, which would be filled in dots. We also have compound inequalities in these particular situations, and how when I want to look at this is I want to look at this in its two chunks. So here's my first chunk, and I'm going to rewrite it so I can work with it. m minus 4, and I'm keeping up, making sure the symbol indeed is facing the direction it's supposed to match it. And these are my two equations, are my two inequalities. I'm going to pause and play these out, and we can take a look at them. All right, I did my usual properties here, the addition property of equality on both sides of the equations. And I'm going to go ahead and do my graph for my solution for m. M needs to be greater than or equal to 1. So here's my 1, and can include it, and it's going to be greater than that. And then m is less than 3, so it's not including it, and it's going to go this direction. And this is an and. I want you to try number 2. Press pause, give it a try, and let's take a look. All right, let's see how you did. Worked out both inequalities. I'm seeing that y is greater than, but not equal to 2/3, and y is less than 6. And this is an and you can tell by that overlap. And also in my original equation. In this particular situation here, I want to get a good grade on a test. So a couple of details in my problem, because this compound inequalities also work out in application situations, and they should. So to earn a B in your next algebra course, the whole thing, we're going to be doing some averaging. So we need to score, here's our 3 scores here, and here they are, plus that 4th score that's going to happen, so we're dividing by 4. And we know that the test average needs to be between 84 and 86 inclusive, so can include it. So that's why I got my 84 and my 86. Now notice a couple of details here. Even when I have a compound inequality, to get rid of my divided by 4, I multiplied by 4, but as long as I do it to all the pieces, it completely works. It keeps the integrity of the problem. So I multiplied everything by 4. The same thing happens down here when I have my 251. I subtract 251 from all the pieces, and I can do that as long as I do it to everything, and I end up with my answers. The 4th test must be between 85 and 93 inclusive. The solution of an compound inequality with an OR, we need to make sure that the answer does work for this. So let me set up the 2 pieces for this. I'll set up the 2 equations, and I'll be back. All right, I'm gonna go ahead and work this out. All right. I'm gonna divide both sides by 3, and I see that t is less than -3. Let's take a look on the right side here. Because I'm subtracting, actually, look at that, I'm dividing by a -4, so my symbol is going to flip to keep up with it. A negative divided by negative will be positive, so my t is also going to be greater than 1. So there is my graph to represent the solution for this compound inequality. Go ahead and try number 4. Press pause and see how you do. All right, let's see how you did. When I graph my 2 inequalities, I can see that y is greater than 3, or y is less than or equal to 2. Now, in these particular situations, you're going to know if it's an and or an or. It's an or because we're going to have the word or in there. It'll be an and if we do the compound inequality like on the last page, where you actually don't see a letter in there. Now we have an interval notation. You're going to use this to kind of communicate a little bit about an answer. A little bit about your graph, okay? So you're going to use parentheses, you're going to use brackets, and the combination of the 2. Now parentheses, oh yeah, and also we got the infinity symbol to kind of communicate when it's forever in the positive direction or forever in the negative direction. So if you look at this first one here, where x is greater than or equal to 2, my graph shows that. And in interval notation, the left number tells me what's going on in the left part of my graph, and the right one is telling me what's going on the right side of my graph. So as you can see here, it starts at 2, but it's a dot. okay, so that it's including that, and I use a bracket to indicate that. And on the right side, it's infinity, and it continues on without stopping. Okay, and that continues on, and I use a parenthesis to represent that. For my second graph here, it is x is less than 2. And so my graph shows that one. And so on the left side, I've got a 2, and on the right side, it's negative infinity. Now my brackets are showing up here because it is, the dot is open, it's not including it. It's not including it, so we need to include a bracket. And just like the infinity sign right here too, infinity kind of keeps going. There's no like end point. So that's why it is a parenthesis. How I keep track of the parentheses would be this. A parenthesis and a parenthesis together kind of make that hollow dot. Kind of corny, but at least you can kind of see when. It might help you keep track of which one to use. A bracket is used when it includes that number and is a filled in dot. A parenthesis is hollow. It's not going to include that. It's like not inclusive of that number. You can see on the third one here, we've got an and with some overlap here. So this tells you a little about the graph. It says that it is a hollow dot. It tells you that it starts at 1. And on the right side, because it has a bracket, it tells you that it's solid, and it tells you it's at 5. So these brackets do communicate to you what's going on, and the parentheses, and the interval notation. It also shows up in a compound inequality with an OR, but it shows up here as you include the OR. So I'm seeing a filled in dot, which is going to show me a bracket. I see an open dot, which is going to be parenthesis. I probably have a negative infinity sign with the parenthesis, and I have a positive infinity sign with a parenthesis. Now this notation's a little unique, but once you get comfortable with it and you start seeing the interval notation, you can actually start seeing the graph before you even draw it. And here's a sample of one. The bracket indicates that -4 is included. Yeah, we talked about all this stuff. So the interval notation here, here's another sample of it. This piece is going on right here. I can see the bracket means it's including it. The parenthesis says it's not. It's at -1, and it just keeps going. This piece right here, I've got a parenthesis, which means that it's an open circle. Starting at 2, and it just keeps going. It's indicated by our graph. Why don't you give it a try and see what happens? So let's pause on 5 and see how you do on this. Excellent. Let's see how you did. All right, so when I looked at my graph, let's move this up a little bit. The graph, so I'm seeing some parentheses here. So parenthesis, that's telling me that's an open dot. And this is telling me it's a closed dot. It's an open dot at -2. It's a closed dot at 7. And then when I look at my graph, I can see here that x is going to be less than 7. It's indicated right here. X is less than or equal to 7. And then I look at this piece here and see that my x is going to be greater than 2. And when I look at the bottom here on B, I can see that 7 is an open circle. I indicate that with a parenthesis. And my infinity, I'm going to parenthesis out because there's no endpoints. There's no endpoints going on here. All right, well, there we go. Inequalities, compound inequalities. Practice that up. I'm going to go and poke a starfish until it bites me.